There you go. Who are the players in this problem? Very obvious here. Fred and Bob. If I had a triangle, I'm trying to make a triangle that has a certain perimeter, then it would be the first side, the second side, the third side, possibly, right? You with me? So your first step in a word problem is, what are the parts involved? In this case, it's Fred's age and Bob's age. This is a little more than a recommendation. Trust me, the people that will make mistakes on word problems are the ones who skip the step I'm about to do. So which one of these? So the first step is, who are the players? Let me kind of summarize our steps over here. Step 1, get a box. No, step 1 is, anybody know that? All right, somebody did, one person. So step 1 is identify the players. Or the parts of the problem, right? Are there 3 sides of a triangle? Are there 2 people? Are there 6 dogs? Amounts of food they're going to eat? Are there what's involved here? Step 2. All right, I got the song in my head now. Step 2 is which one is just X? Now, what do I mean by that? Do I know either one of these ages? No. What's wrong with me just calling them both X?
Because they're not the same.
That would imply that I somehow know they're the same, and I don't know that they're the same, right? You guys, are you cool with that? So you can't call them both X. You go, well, Jeff, man, I call anything X that I don't know. But if you call them both X, you are saying something. You're saying that they are the same. Nowhere up here does it say they're the same. So which one of them should I call X? Because the other one has to do something to that. Which one of these guys' ages should I know first? Bob. If I knew how old Bob was, I could just take subtract 8 from it to get Fred, right? You guys see how to see that? So Bob must be X. And then Fred must be
the 8 years old.
younger. X minus 8. Younger. Don't make poor Fred suddenly. So the people that skip this step, the equation they set up is this. Because they'll focus on 8 years younger, and they'll say, oh, that's X minus 8, and 72 is the number they gave me. What did they do wrong? What does this first thing say? It says when I add up Fred and Bob's ages. I've got Fred's age over there. Who did I forget to add in? Poor Bob dude is left on the side. So it's got to be Bob plus Fred. Okay, cool. And now you can solve it. So see, that is the difficult part. Getting the players from there, figuring out who's X, figuring out what the other pieces are, and then getting the equation together. What should be the easier part, some of us are still getting used to this, is actually solving that equation. So how do I solve this equation? Good. I can put the x's together. 2x minus 8. Add the 8. Divide by 2. Now there's 2 things wrong if you just stop, you just circle that and you keep going. 2 things wrong with that. Number 1, I'm going to be a real dork. I'm going to say 40 bananas, 40 whales, 40 shoes, 40 what? And number 2, the question is about 2 people. You give me one number. What the hell? So this step helps you set the equation up, and it helps you answer the damn question. Who's 40 years old? Because he's X, right? X is 40, so he's 40 years old. So how old is Fred?
32.
Yeah, 40 minus 8, 32 years. How do you check your work? It's not even plug it in now. It's nice. What are the 2 ages supposed to do? And what do they do? So much easier. It's actually much easier to check your work in a word problem. It should be, because there's a lot of work just to get there. So let me let you guys try one on your own. See if you guys can handle this. Let's see. Maybe this is a little bit more interesting, sorry. Wait, sorry. Give me a second, sorry. I'm trying to make one a little bit more longer piece. Come on, Jeff. Is 2 feet more than twice. By the 2 lengths. Now, real quick word. A lot of us can probably get the numbers without doing a single bit of algebra. And then you say, Jeff, why do I need algebra? I did the problem without algebra. This is a very simple problem. It's very simple for right now, so we get used to doing the algebra, but we feel comfortable to know how to do this another way. So we're not totally like hanging on our own now with just algebra. There are much more difficult problems I can give you that there's no damn way in hell you can solve it without algebra. So we desperately want to get the practice now. If you give me the right answer, but you didn't know algebra to get there, you will lose almost all the points. Let me say that again. If you don't do the algebra for these problems, even if you get the right answer, you will lose most of the points. Why? Well, what's the name of the class? Okay, there's your answer, right? So, even if you know the answer just by thinking about it for a minute, you still want to set it up, and the great thing is you already know the answer. So you won't be surprised if you get it. So try to do what you can. Go through the steps we went through for the first problem. Let me maybe help us out a little bit. How many players are involved?
2.
2. What are they?
Egg.
Beautiful. So
Longer
use
and
the
shorter.
same exact language that the word problem uses. So you can always see the connection. There's a longer piece and a shorter piece. Good, so that's step 1. Step 1. X, so. Let me catch up to you a little bit. Which one of these is gonna be just X?
The shoulder.
Yeah, why?
Because we don't know.
Yeah, because you gotta do crap to the shorter one to get the long. The longer one is 2 feet more than twice. Oh, so I better know this guy first so I can do this stuff to it. So it's, I make a big point there because the most important step just about in a word problem is identifying the X correctly. If you don't identify the X correctly and you try to build on that, what are you gonna get crap? So definitely the shorter one must be X. I gotta know him first. And then what's the longer one that I can build off of that?
2x plus 2.
I like it. 2 feet more than twice this guy. So twice this guy plus 2. How we doing? Now, I purposely gave you one that doesn't tell you directly what to do with these. But since the wood was 14 feet long to begin with, what do these two have to do?
Go 14.
When you do what with them? Add, good, right, that's the important part. Not multiply them, not anything. If I add this piece back to this piece, it should be 14. And I'll tell you this real quick, about, I don't want to even admit, what was it, 13 years ago? The second year I was teaching, I had this guy in the class, he said, Mr. Waller, I'm a carpenter, and I happen to know that when you cut a piece of board, some of the wood gets stuck in the teeth of the saw, so that it's not gonna come out. I said, now listen, I said, you could do your problem, including the 1/8 of an inch of wood that comes off in the saw if you want to. Math is all about ideal situations, you with me? So I like, no, he wasn't even an asshole or anything, he was just,
I didn't say
I was kinda like, I appreciate that, school, you know.
I said technical, not asshole.
Oh, technical, I'm sorry. Well, my first thought is, I've had assholes say basically something like that before, but he wasn't one of them. So, now you just gotta solve it, and now I'm hoping you guys see that the easy step should be solving this thing. It was difficult to get here. How do I solve this? 3x. And then I can subtract the 2 over. And then almost always my last step, divide. So x is 4. So who's for what? Shorter one is for what? 4 miles long, 4 feet long. Good. And so that makes this guy 2 times 4 plus 2. Is that cool? Because now we know x is 4. I can plug a 4 in. 8 plus 2, 10 feet. And does it check out?
Yes.
10 and 4 is 14. Sweet. If you subtracted your 1/8 of an inch and you add it back in, it should work out there. All right. Are there any carpenters out there? Anybody do carpentry? Carpentry? Does that sound about right? I mean, you lose some of the wood in the saw.
Yeah, you have to normally compensate for the saw when you're passing it through the table.
Exactly. Cool. So you know what I'm talking about. We won't be taking that into account. Hopefully it's all right. So let's try 2 more word problems here, and then I want to do a little preview of the next chapter. Everybody have their book? So I don't have to write all this out on the board?
Yeah.
Page 193, number 38.
Question related to the next one.
Native Americans. Number 38. Oh yeah, that's there. make sure we're all getting off the right foot here. What's the first step? What do I write down for the first step?
California and Washington.
All right, so California and Washington, and just realize they're both number of Native Americans in those places. Cool.
And then you find X.
Oh. Just a second. You want to do it up here?
Yeah.
Sure. Sure.
I can do it here?
Okay, sure. All right. So, which one is going to be just X?
Washington.
That was
And that's because California has,
3 times Washington.
yeah, 3 times that of Washington. So I got to know this first before I can triple it. Cool. Guys, So what's here?
California, 3x.
I love it. So be careful about what operation to use. They didn't say there were 3 more Native Americans. It won't be X plus 3. There's 3 times as many. So 3 times X.
So 3x added to x equal 412.
Was it 412?
412. So it will be
1,000.
4x.
Now you could do this, and there's no reason why you really need that, to tell you honestly. It's just whatever answer you get, you could just put the word 1,000 at the end of it. So you could actually just use the number 412. As long as you put the word 1,000 after your answer. But we'll just keep it like that for right now.
So 4x.
Good. 4x.
And then we divide.
And then divide by
4.
4. X equals
103,000.
103,000. So who's that?
Washington.
So then you go back. You can see which one's just X. So Washington, right?
And then
103,000. And then 3 times 103,000.
309.
309. I'll forgive you.
And then we added 309 to 103, so it will be 402.
Now even here, I'll be a little bit of a dork, and I'll say 309,000 astronauts. So, but at A, I'll know you mean Native Americans, not applicable. Okay. Cool. So I'm trying to get you ready if you have to do any science classes. Science people are definitely big on units. What did you just measure? What is this? Is it in miles? Is it in centimeters? So we just measured the number of Native Americans. Cool. Okay. All right, so I'll tell you what. That section, and again, I'm going to say this. Basically, every problem is the same. You find out what X is, and the other one's going to be 7 less than that, or 3 times that. Maybe even 2 more than twice that, like we had here, right? So that's why I had to do that first little bit about how to translate. Just translate one little piece from English to math, because now it could be a part of a bigger word problem. I want to do a little preview of the next section. And actually, I just want to get a gauge of how much you're already able to do. And as much as students normally don't like word problems, they at least equally don't like fractions. And that's what chapter 4 is all about. Oh, yeah. So let me give you a couple problems just to try, just to see kind of like where we are, what you're able to do. Oh, let's see what I don't get too deeper than this goes. Can you guys see that? So write that as a mixed number. Write this as an improper fraction. So part of this is, do you know what those words mean? And the other part is, can you do it? Finally, one last one here.
I'm still working on chapter 3.
You're good. We're just getting into 4. You're fine. Oh, let's do. While you guys are starting to work on that, I just want to remind you about something. Obviously, a few of us, there were some questions already from section 4.2. There's not a damn thing wrong with getting ahead. That's why I give you all the homework on the first day. All I ask from you is, if you are somebody who's able to do a lot of this stuff and you get ahead, and that's great, don't take away from the rest of our ability to talk about this. So what I mean by that is, you come to class and you've already done a lot of this stuff, don't have a lot of conversations with other people so that it's hard for people to concentrate on what we're doing. Just hang out. Don't not come to class, because you never know what might be said that actually helps you with something you have trouble with. But get ahead, not a damn thing wrong with it. Just don't annoy people around you, right? Alright guys, so this first problem, 1/3. Yeah, in fact, go through the steps for me. How many parts do I have total? 6 total parts, right? So it's not a whole thing filled. I'm thinking about this, maybe this is an ice tray, and I can see the ice in there. There's not one complete ice tray full of ice, so there must be some fractional part of this ice tray full of ice. So there's 2 of them have ice out of 6. So that's really the fundamental idea of a fraction. It's just to give us an idea of the part out of the whole that's doing some filled up or used or whatever. I often think about my gas tank. Should have got an eighth of a gallon, eighth of a tank left. So 2 parts out of 6. Now, here's the cool thing. If I look at it like this, so you see those parts that I outlined in blue? Sort of. Ah, screw it. So here's 1, 2, 3, right? And they're all equal parts, giving my picture a little leeway with how bad I draw. So then I could look at it a different way. I have 1 part out of 1, 2, 3. And of course, that's just another explanation as to why this reduces to 1/3. Now, of course, the quick way to reduce this is not to draw a little ice tray and to fill it in, is to divide both top and bottom by. How do you reduce this directly? What goes into both of these? 2 goes into both of them, right? 2 goes into 2 once, 2 goes into 6 3 times. There you go. That's the direct way to reduce it, right? That's hopefully the way you're trying to attack that problem over there. Okay, so what does a mixed number mean? Do I have a mixed number on the board somewhere? Yes, I do.
Yeah.
That's a mixed number, right? Why do we call him a mixed number? He's got a whole part and a fractional part, so that's why we call it a mixed number.
So would you turn it into one of the, like, 15 on the side?
Yeah, I won't do it like this,
Or would you turn?
but I want to turn it into that, yeah. I want to make it look like this.
So it would be what? Wouldn't something on the side?
We actually know exactly how to do this. 7, what is 15, what does that really mean operation-wise?
How much can 7 go into 15?
Yeah, that's the division bar, right? So you actually just kind of start doing it. And I'll show you a much better way to do this, by the way.
Where's 1?
7 goes into 15
True.
twice
One you made.
with 1, and anybody remember? Now don't do this. What's wrong with that? I've seen this a couple times. What's wrong? What's the only time I can use decimals? What kind of fractions are decimals? I know I'm getting way ahead of us. But decimals are based on fractions out of 10 or 100, multiples of 10 on the bottom. What's this going to have on the bottom?
7.
7.
1 7.
I like it. Cool. Now, let me focus on this for a minute. Let me give you another way to look at that. Here's a really cool way to look at this. If only it wasn't a 15, if only it was some number close to that, a 14, why would 14 be better up there? Because then 7 goes into 14. So 15 is 14 plus 1, you with me? Right? So I could write that if I really wanted to. And then I could split them up. What's being divided by 7? 14 is being divided by 7, and 1 is being divided by 7. So 14 divided by 7 is 2. And 1/7. So that's really what's going on when you're changing something from improper to mixed. You're seeing how many whole things does it go in, and then the remainder is left. So you really could rewrite it as something that goes into plus the extra. So for example, if I had 31 over 6.
5.
Yeah, I could write it as 30 plus 1 over 6. That's 5 and 1/6. Okay, see that? Now, not to take away, you could always do it this way too. Nothing wrong with that way. That's kind of a neat way just to do it in your head, possibly quicker.
Where did you get the 2 on this one?
Where? Sorry?
On the, yeah, that one. Where'd you get
14 divided by 7.
Oh.
Cool. All right, how do I change it back?
You multiply
Good.
3 times 7 plus 2.
Yeah, and think about this. 2 is because of the 14 piece, plus 1 was the 15, right? So because of the 14, that's why I have 2 here, because 7 goes into 14 twice. So 7 times 2 is 14, plus the extra 1 would get me back to 15. So that's the little thing we can draw. 7 times 3 is 21 plus 2, 23. There you go. So it's 23/7. You can see the extra 2 sevenths, because if only this was 21 seventh, it would be nice. But we have an extra 2 sevenths, yeah.
Can you repeat it, like 3?
Yeah, 7 times 3,
Yeah, then,
21 plus 2, 23. You're adding that remainder back in. Okay. How are we doing so far? Hopefully, this sounds familiar. Some of us, it might be a long time since we've done it. Finally, what's this guy? What can I do to the top and the bottom?
See what divides
Evenly. What's the only thing 49 can be divided by?
7.
7, because 49 is 7 times 7.
To both of them.
So I can divide both the top and the bottom by 7. And what do I get?
4/5. 4/7.
4 sevenths. Cool. I like it.
And then
All right. That's plenty. Next time, we'll just keep on going to chapter 4. Our test is still, I'm going to keep it on the 9th. It'll just cover as much as we can cover. So it's currently scheduled for Monday the 9th of October. It's going to stay there. All right, guys. I mean, not Monday, but Tuesday.
Have a good day.
Okay, you too. Did you get the original? Oh, yeah. Oh man, that's the advanced math.